G'day, welcome to another video on vector basics. This video will be covering the vector or cross product using matrices and determinants. We have two vectors here, the vector v, which has the components 1, 3 and 5, and u, which has the ijk components of 2, 0, 2. Now, the vector product of two vectors is going to give you a resultant vector, which the plane that the two vectors that you're taking the cross product of make, the resultant vector will be pointing out of that plane. So if we take the whiteboard here, for example, the plane that these two vectors make on the whiteboard, the resultant cross product will be pointing out of the page. So, matrices and determinants. A cheeky hint to remember for matrices and determinants is when taking the determinant of a 3x3 matrix, you are having positives in the four corners and the center, with the other four places being negative. So the cross product of v and u. Now, if you're not particularly confident with matrices or determinants, or you don't know what I'm talking about at all, then you can go to another video of mine that covers matrices and how to find the determinant of a 3x3 matrix. So the cross product of v cross u, we write as a 3x3 matrix. Just make that a little bit bigger. Where our top row is I, j, and k. We have v being the second row, and we have u being the third row. So we have 1, 3, 5, and 2, 0, 2. Now, remembering that rule about positives and negatives, we're going to be taking the top row for our determinants. So for our first column, first row, we have I times our matrix minor, which is 3, 5, and 0, and 2. It's minus j because it's a negative. And that is a 1, 5, and a 2, and a 2. And then it's plus k which is 1, 3, and 2, 0. And remember, with taking the determinant of a 3x3 matrix, we are multiplying a times d minus b times c. So for I, we have 6 minus 0, so it's 6i. We have minus j, 2 minus 10, so it's minus 8. So we have plus 8j, and then with k, we have 0 minus 6, which means we have a minus 6k here. Or in standard vector notation, we have 6, 8, and minus 6 as the vector cross product of v cross u. So that was a simple example of the cross product of two vectors using matrices and determinants. You can double check my other video on Sarris's rule to confirm that this is the answer you should be getting. If you have any questions or comments, please leave them below, and I will see you in the next video.